Okay, today we're going to look at triangle fundamentals, things that you probably already know about a triangle maybe. We'll see what you think about that. First of all, the triangle sum theorem. This is the part I think you really should already know. The sum of the interior angles of a triangle is 180. Let's look at an example. If you have three angles in a triangle in which x is what you want to look for, find x, then the three angles in this triangle should add up to 180 is what this theorem says. So the measure of angle A plus the measure of angle B plus the measure of angle C, the three corners on the triangle, equal 180. So if you set this up, you would say A is x, B is 117, and C is 33. Now we all know how to solve equations backwards because we know you're only supposed to have two items on the left side. So let's add those like terms. That's 150. And then the opposite of adding is what? That's right, subtraction. And 150 from that makes 30. So 180 minus 150 is 30, and that is how many degrees that corner is. So this is a property that you're very, very familiar with. But I'm not so sure you're familiar with the exterior angle theorem. So let's take a look at it. So the measures of the exterior angle of a triangle is equal to the sum of the measures of remote interior angles. So let's go over that vocabulary. Where is an exterior angle versus where is a remote interior angles? So your exterior angle is between the line and the side of the triangle that's extended past the vertices C, and that is on the exterior of your angle. It is a linear pair with the angle at C on the inside. Your remote interior angles are the other two vertices or corners of angles in which they do not touch the exterior angle, so that's why they're very remote away from the exterior angle, and it's the other two angles on the inside of your triangle. So what it's saying here is if you add A and B together, these two angles on the inside of your triangle, that they should add up to this outside angle. And we have an example. It says find the measure of angle A. So that means that these two angles at x and 80 are the remote interiors because they don't touch the angle on the outside, and that they should add up to the angle on the outside. So that makes our equation 3x minus 22 for the exterior angle is equal to the two interiors, x plus 80. Now you should stop the video and solve for x so that you can find the measure of angle A. Okay, so let's check your answer for the measure of angle A. So first we would need to take x away from both sides. That'll be 2x minus 22 equals 80. Now we know that the opposite of subtraction is adding, so if I add 22, that's going to give me 2x equals 102. And then, of course, the opposite of multiplying is dividing. So when I divide by 2, I get x equals 51 degrees for the measure of angle A, because angle A was just to find x. If I had asked for the exterior angle, I have a couple of ways I could have found that. I could add the 80 and the 51 that was from angle A, or I could plug in 51 in this outside equation to see what it is, or I could do both, and that would be a great way of checking it. So that's the exterior angle theorem. So now, let's look at some more examples. So the angle theorem that you're most familiar with again is the fact that the three angles inside of a triangle add up to 180. So the measure of angle 1 plus 44.7 plus 52.2 is supposed to be equal to 180. So this is a great opportunity for us to practice our addition facts for decimals, because we don't get an opportunity to try that very often. Let's add the 44.7 to the 52.2. Now that would be 9. I don't have anything to carry. Add the 4 and 2 together, and that will be 6. Don't have anything to carry. Add the next column and get 9. Bring your decimal straight down. So we've added our like terms and found that the measure of angle 1 plus 96.9 is equal to 180. Then we need to subtract. Oh, this is a great opportunity for us to try that as well. So let me come over here and say 180 minus 96.9. Now, in order to subtract, we need to add a decimal point and a 0. Let's borrow from the 8, which turns that into a 7 and gives it to the 10. And let's borrow from the 10 to give to the first column to make it 10. So 9 from 10 is 1. 6 from 9 is 3. And 9 from 17 is 8. Bring your decimal straight down. So the measure of angle 1 is equal to 83.1 degrees. Don't forget that degree mark. So that's a very simple way of finding a measure of an angle. Is just add the three of them up. By subtracting off what the ones you know, you can find the one you don't know. So stop the video now and try question next to this one to find the measure of angle 1. So let's see if you got it right. So the measure of angle 1 plus 33 plus 57 equals 180. So you added the like terms together, which would come out to be 90. And so therefore, if you subtract 90 from 180, you find the measure of your angle is 90. You can see that this picture is not drawn to scale because angle 1 does not look 90, and therefore that's a really good point, that pictures are not always drawn to scale. Now let's look at a little bit of a different thought process here now. In this problem, we're asked to find one of the interior angles and an exterior angle, and I want to look at those in a little bit different ways. First, the measure of all three angles in a triangle have to be 180. So we want to take 180 and set it equal to y plus 33 plus 42. Now y plus, let's add these like terms together. And that comes up 76. And let's take 76 away to find out that y is, borrow, make that 10, 4, 104 degrees. Now that's one way to find angle y. And so then we know that x plus y also makes 180. And that means that x plus 104 makes 180. So if I take away 104, I'm going to have to borrow again and find out x is 76 degrees. Now we just learned a rule that said the remote interior angles have to add up to the exterior angle. So while we were over here adding the 33 and the 42 and getting 76, we actually found that exterior angle, because the two angles that don't touch the exterior angle have to be the same measure. These two angles have to be the same measure as this angle. So this picture also is not drawn to scale because the obtuse angle is on the outside on the picture, but it's really not, but it's on the inside. So you've got to understand these pictures are not always drawn to scale. You have to do the math to find the information. You can't go by looks. Now in this picture, I'm not asked to find any on the interior. This is a true example of what we were just talking about. These two angles on the interior have to add up to this exterior angle. So 42 plus 28, carry a 1, 70 degrees. Again, it's not drawn to scale, So I could not have realized it was going to end up being a cube because it looks obtuse in the picture. So that's a way of finding it without having to find that answer on the inside. That's why this rule was developed. So let's look at this one. This is a totally different thought on this picture. You have two 90-degree angles, and you have one angle in this top triangle is 30. So if you have, let's just say we want to find this angle up here. So if we want to find that one, we know that 90 plus 30 plus that something makes 180. And so therefore we know that you can add those together and take it away from 180 and find that your answer up there is 60. Now these two angles are two lines cut by transversal such that the bottom left corner are both the same. So C has to be 60 degrees because those are what we call corresponding angles. So they can even bring that back into this triangle to help you figure out that angle on a different triangle. So see what you can do with this picture. Try working your way through the picture. Find as many angles as you can. Pause the video. Okay, so you have tried finding as many of these angles as you can. So we're looking for how many degrees X, Y, Z, and W are. So let's start with X. X has to be 180 minus 80 minus 30 because that's the two angles inside the triangle that would add to it to make 180. So 180 minus 80 is 100, minus 30 is 70 degrees for X. Now if X is 70, we know the one beside it has to also be a linear pair, so that means it has to add up to 180. But if you look at this picture very carefully, Y happens to be the angle on the outside of the smaller triangle. It's that exterior angle. So I could just add 80 and 30 together and find it's 110. Or I could add this, realize that X and Y add up to 180 and subtract 70 and find it's 110. So I can find it more than one way and be able to check my answers. Now, that's true also about Z. In Z, you've got 40, 110, and Z, so you could do the 180 rule, where you say Z is equal to 180 minus 40 minus 110, and therefore minus 40, it'll be 140, and minus 110 would be 30. But I could have gotten Z another way, so let's look at that. This whole picture is a triangle. So if this is 80 in this corner and this is 70 up here, 80 and 70 make 150. And with the 30 in the corner with Z, that also makes it work out to be 180. So that's a good way of checking it, taking the different pictures and putting them together. And that's also true over here because 30 and 40 make 70 and the 80. But this is the exterior angle to that triangle. So therefore this has to be 150, which makes sense because 30 and 150 make 180. So there's so many different rules you can use to check yourself to make sure that your answers make sense. They have to add up to 180 inside of a triangle. The outside angle has to add up to the two remote interiors. Two angles side by side make 180. So you've got a lot of things there you can work with.